this will probably be a short video since I'll have to do some cooking soon. But as I've mentioned in the previous stream/episode, we will be using our contact information here to do some physics resolution. This is our new collision resolution step. We'd actually want to, this is collision checking. This doesn't actually do anything anymore. Let's move this. Yeah, we have player collisions, which are a separate thing. We have general collisions, and we have our physics stuff here. And we have our queries, which we will close for now. Yeah, I think we'd want inside collision resolution and physics. Instead of let's particle based physics and then rigid body based physics. And we want a void function where we calculate some contact transforms, and we take in a vector of g vectors contacts, which we reference, and then we output some matrices contact space transform. Yeah, and we will do that. So for const auto reference contact in contacts, maybe we want an index, so I always do this instead of writing the indexed one, and then I always end up doing it over. Anyway, let's see. Then we want to calculate a transform that is able to rotate from the world space into the contact normal, where you set the contact normal to be one of the local axes of a local coordinate system. So yeah. That will be what we do, the absolute value of something we will check whether one of the axes of this contacts. Let's see, the x-axis is greater than the x component is greater than the y component. If that is the case, we calculate a constant float. That is the scaling factor of 1.0. Let's do contact normal, so it will be easier to read since it's not contacts as per se. Then we take the set component and square it. Plus the x component and square it. That's the scaling factor. We create a vector. X-axis. Where we initialize it as the C scaled. Zero at the Y since it's going to be. And we will put the last component as a 0. And then we will do the g-vector y-axis, which is equal to well, the contact normal ends up being the c-axis actually. Or rather, no, nah, never mind. It's still the x. Then we take the contact normal y component and multiply it by the x-axis x component. This is basically a cross product in the making. And we have the C component of the contact normal, which we multiply by also the x. minus the contact normal x times the x-axis C component, and then we take the negative y component of the contact normal and multiply it by the x component of the x-axis, and then we set the last component to 0, 0. All right, let's just check this. So the first one has the C component scaled, then it has a 0, then it has the negative x component of the contact normal times the scaling factor, and we have the contact normal y times the x-axis of the x component of the x-axis, then the second component here. Well, we could do something like this to, oops, we could do something like this to make it more readable. Let's see. So the first component, the y times the x of the x-axis, then the c times the x of the x-axis minus the x of the contact normal times the c-axis of the x-axis. Then we have the negative contact normal times the x-axis. There we go. And otherwise we will do something almost opposite. The contact normal c-axis plus the contact normal. Wait a minute. Did I do something wrong here? No, it's the c-axis squared plus the x-axis squared, but down here it's the c-axis squared, which it also was up here, and then it's the y-axis squared. Or rather, not axis, component, of course. We do an x-axis where we set the first component to 0. Let's see, let's do this as well in the other versions. There we go. And the second component is equal to the contact normal negative contact normal times the scaling factor. Then the next one is the contact normal y times the scaling factor. Then the y-axis is equal to first the contact normal y-axis times the x-axis C component minus the contact normal C component times the x-axis y component. The next one is the negative contact normal x component times the x-axis C component. And then the last one is the x component of the contact normal times the y component of that. And then we, let's see, G matrix match. We set mat D0 to the contact normal. We set mat D01 to the x-axis. And we set the, I know this is weird. We should actually call this the y-axis and then the z-axis, but yeah, y-axis. The last component is supposed to be do we want translation? No, we do not want translation. Therefore, we do like that. And then we do out. Maybe just move it. Can I do that? Yeah. All right, great stuff, great stuff. Now we can actually transform this by transposing, or rather get the inverse by transposing it. All right. Let's see. Did we implement? Yeah, we did. Physics. Let's see. There we go. Anyway. That is one stepping stone towards implementing some physics resolution in here. And we already have some nicer code, it seems. We can settle on this one. We will implement this fairly soon. But right now I'll have a break, do some cooking. I'll be seeing you around. Hopefully you like this short one, and I'll be catching you on the stream or just on YouTube.